Hello there. Welcome back. We're going to continue our discussion with finding extrema, extreme values on a function by using multivariable functions, so looking at a three-dimensional surface. Today we're going to look at finding the extrema, though, if we have a triangular region given by, let's say, the vertices 0, 0, 0, 2, and 4, 0. Remember, we are trying to find the absolute maximum values, and as we learned in Calc 2 or BC last year, this is our candidates test that we have to use. So we're given a triangular region on this domain. Remember, in multivariable, our domain is in terms of x and y. So this is basically looking at, on the xy plane, we're looking at a flat surface and we're looking at a triangle on that plane. So I can draw that triangle. We're looking at the first quadrant. So we're at 0, 0, 0, 2, and at 4, 0. And we're looking at this triangular base. And remember, we are going to project this base, this triangular base, onto the surface. And what we want to find out, if we project that onto the surface, there we go, if we project this onto the surface, what we're looking for is, in that surface, that projection, where is the absolute minimum, where is the absolute maximum. Now, we've been talking about this for about a day or so. So the first thing we need to find is our relative extrema. And to do that, we're looking at the partials, so looking at the relative extrema. We look at the partials of our function. And we saw this in our video the other day when we talked about the second derivative. So we're going to get 1 minus y, and my partial with respect to y is going to be 1 minus x. And of course we set both of these equal to 0. Oh, this is nice. This turns out nice. So we get x equals 1. Whoops, sorry, that's y equals 1. Excuse me. We get y equals 1 and x equals 1. So my first possible candidate is going to be at the point x is 1, 1. So my first possible maximum or minimum value is going to be at the point x value 1, 1. And I'm going to check, is that in my region? 1, 1, it is in my region, so it is a possibility. So next we have to check the edges. And this is where it gets a little bit different than what we saw yesterday. To check the edges, I have to look at these lines. Now, of course, my one line over here is just x equals 0, or in this case y equals 0. So my first edge would be y equals 0. Remember, these are the traces of the bounds in the function, where those bounds meet the function. So my first bound is going to be the line y equals 0. It's this bottom of the triangle. So I'll let y equals 0, and if I let y equals 0, I can plug that into my equation, f of x, but y be 0, and that's going to give us just x. And because if y is 0, that just becomes 0 right there, so we don't have to worry about that. So what we're left with, so I am looking for the critical numbers, so we take the derivative. So I'm looking for the critical numbers, therefore we need the derivative. This one's kind of neat. When I take the derivative, we just get 1. And remember, to find a critical number, we set that equal to 0. Well, 1 can equal 0, so therefore this is a D and E. There will be no critical numbers on that particular edge. My next one is going to be, of course, let x be 0. So let's go ahead and try that. So if we let x be 0, we would get our function. And this becomes, if I let x be 0, we would get 0, we would get y, and again that just becomes 0. So again, find the critical number. We take our derivative, and that's just going to, with respect to y, and that's going to become 1. And again, if I set this equal to 0, and that's never going to happen. So again, there's going to be no critical numbers or critical points on that edge as well. Now we do have one more edge, and that's right up here. That's this line right here. So I'm going to write the equation of that line, and that's just y equals 2 minus, and it looks like down 2 over 4, so 1/2 x. And there's my other edge. I'm going to plug that in for y. So my next one is if I let y equal, this is that line right there, 2 minus 1/2 x. And if I plug that in for my y value, let's see here, go back up to the original function and plug that in for y. So we're going to get x plus y, so plus 2 minus 1/2 x, because remember that's my y, and then it goes minus x times y. So I'm going to multiply this by my y value, which is this, of course, 2 minus 1/2 x. If I simplify this, we're going to get x plus 2 minus 1/2 x minus 2x plus 1/2 x squared. Keep simplifying. That becomes negative 1 minus a half, so negative 3/2 x plus 1/2 x squared. Now over here our critical numbers gave us nothing, but over here when we take our derivative, we would get our derivative being negative 3/2 plus x. So set that equal to 0, we would have a critical number at positive 3/2. Now remember, there's my x value. We still have to find our y value, but we can do that over here. Y is equal to 2 minus 1/2, whatever x is, 3/2. So we would get y equals 2 minus 3/4, which is 1 1/4 or 5/4. So my next critical number is going to be 3/2 5/4. That took a lot of work to do. So we have our extreme value. That's easy. We have the edges. We only got one point that worked there. And now remember, we have to look at the corners. Well, to get the corners, that's pretty easy to do. We can just go look at our graph. We got 0, 0. Oh, it's just basically the points they gave us for the vertices. 0, 0, 0, 2, and 4, 0. So we got 0, 0, 0, 2, and 4, 0. And now we're going to go ahead and apply our candidates test. Make a long little table there. Our function, our x coordinates and y coordinates, and our function. Now remember, our function, what was it? It was x plus y minus xy. And you're going to plug in all of the points that we have. So the first one we got was 1, 1. That was our one critical number that we have. 1, 1. That was our critical point. And then we have 3/2 5/4, and that was our edge from the edges. And then we have 0, 0, 0, 2, and 4, 0. These were our corners. And we just plug them in. Okay, so if I plug 1 in, that's easy. We get 1 plus 1 minus 1, so that's 1. Plug in, that's a little harder. Plug in 0, 0, that's just 0. 0, 2, that's not too hard to do. 0 plus 2 minus 0, that's 2. Plug in 4, 0, we would get 4 plus 0 minus 0, and that's 4. And now we just got to plug in our one edge. That's going to be 3/2 plus 5/4 minus 3/2 times 5/4. So let's see if we can do this. That's 4, carry that's a 2, that's a 6, so we're going to get 11/4 minus 15/8. Make that an 8, that becomes 22, so we get, what's that, 7/8. Alright, so not too bad to do. So now we can get our answer. Our absolute maximum value, the biggest value is going to be is 4. That's at 4, 0, 4. And our absolute minimum, that's going to occur at the origin, 0, 0, 0. And there we have it. Alright, hope you enjoyed this video. Plenty more. Smash that like button. See you soon. Bye.